All right, fair warning. Okay, so here's what I suggest then. Why don't we've got 8 people here on my phone. Why don't we go around and just everybody, if you don't mind, if you've got a microphone, introduce yourself. If you can't introduce yourself, you can just wave when it comes to you, or we'll move on. We'll just go around to at least everybody who has a microphone and is willing to talk or can. So I'll start and say that my name is Jason Hoden. I'm a research scientist at Friday Harbor Labs at University of Washington. And I'm the director of this project Bonds Across the Water, which is funded by NOAA through their Pacific Northwest Bay Watershed Education and Training program. And I'm really happy to be here with a bunch of my colleagues, the teacher colleagues from Washington, and other participants here who I'll just go ahead and maybe let Nicole introduce herself next.
Hey, hi everybody, I'm Nicole Harris, and I am the Education and Outreach Specialist with NOAA's Olympic Coast National Marine Sanctuary. So I run a lot of informal education programs, teacher workshops, from planning and developing and implementation to evaluation. And I just love the ocean and the sanctuary, so I get stoked about any program we can do that encourages that love. So I'm looking forward to working with everyone.
Thanks, Nicole. Karen, you want to go next?
Okay, sure. And I'm only on audio. I'm Karen Matsumoto, and I am a climate change educator with the Suquamish tribe. And I've been working with Ecosystem Pen Pals program for about maybe 6 years in different iterations. And I'm really excited to work with Bonds. I think that's good.
That's great. Sean, you want to introduce yourself real quick?
Sure, happy to. My name is Sean Russell. I'm the Earth Echo Water Challenge Manager at Earth Echo International, and excited to dive into the work with this program with all of you as we work to integrate water quality monitoring and citizen science in the work that the students are involved in.
All right, now let's meet some of our teacher colleagues from Washington. Alice, you want to introduce yourself? Okay, your microphone.
There we go. I had to unmute it.
Yep.
Hi, I'm Alice. I teach 7th through 12th grade science in La Push, Washington. So right on I've got a ocean and river right outside my door, at least until we move. But really looking forward to this project and getting to know more of you better and pulling my kids in.
Great. Alicia, would you like to introduce yourself?
Hi, I'm Alicia Boisvert. I'm a science teacher in Olympia, Washington, so 9-12, and happy to be a part of this group and really looking forward to the connections we can make across the water for real. So thanks for being here.
Thanks, Alicia. John, are you on microphone now?
I'm on microphone. I'm on the phone, I guess. I don't think you can see me. But I teach science at Forks High School in Forks, Washington. And I have been kind of pushing a citizen science engagement, getting kids outside and doing science that connects with where they live for about as long as I've been in this position. So.
Thanks, John. Nale, would you like to introduce yourself or just wave? I think your microphone is on now. Oh, just went off again. Hold on. I can unmute you, I think. Oh, unfortunately, I can't hear Nale. I don't hear you. I did see that your microphone was unmuted, but for some reason I wasn't hearing you. sorry. So yeah, hi. And if you, Nale, if you see that there's a way to type messages, you can type an introduction if you want to, and it'll show up for everybody. Sorry about that, that's not working. And Jim is on here. I'm not sure which Jim this is, but would you like to introduce yourself, Jim?
Hi, yes. This is Jim Foley, the Be Wet Hawaii coordinator.
Oh, hi, Jim.
Sorry, I'm a little late. Yeah, I got a sick kid today. So.
Oh, no problem. Thanks for coming. So now that we've had a chance to meet everybody, I'm going to switch over and start sharing a presentation that has integrated with a whole bunch of us have included slides, and we're going to sort of trade off talking about different aspects of the project. So for most of the rest of the time, I'll be showing the presentation here, and that is let's see. Hold on just a minute. Here we go. Okay. So let's see. Okay. So I just wanted to show you the cute little Bonds Across the Water graphic that I made yesterday. So the Bonds Across the Water project is designed to connect students to global environmental concerns through local watersheds. And a major part of the project is local field and laboratory studies, and we are centering the project around issues of climate change and ocean acidification, as we'll get into, and multiple interacting aspects of those problems. Our project also is committed to integrating indigenous knowledge systems, and one unique part of our project, which builds on this previous project that Karen mentioned called Ecosystem Pen Pals, is to support communication among students across the water, in this case, in our different locations, about shared environmental problems and their local solutions to addressing them. So here's a picture of all of us together in Forks, Washington a couple of weeks ago, and at the field site that we went out to do our water quality sampling. That's land owned by one of our partner teachers, Kim. So, and we've already basically introduced ourselves, but I'll just show you, you can now see a picture of Karen and Sean and Nicole. And some of our partners across the water are Isabel in American Samoa, Andy in the Papahānaumokuākea Marine National Monument in Hawaii, Patty Miller in Maui at Humpback Whale National Marine Sanctuary. That's me. And Karen is going to start us off here with a very brief version of a presentation that she put together on indigenous knowledge systems.
Okay, this is going to be, oops, this is going to be super brief. Actually, this, do you want to just go to the next one? And basically, as part of this cultural exchange, we really want to acknowledge indigenous knowledge systems. And I think a lot of times they use the terminology traditional ecological knowledge, TEK. I'm going to go with indigenous knowledge systems because I think a lot of the tribes these days really relate the TEK nomenclature to more resource management. And so we really want to acknowledge culture and education here. And so to define these indigenous knowledge systems, it's the evolving knowledge that's acquired by local people through direct contact with the environment over many generations. And it's definitely place-based education and specific to a location, and really emphasizes the cultures, the people's connection to culture and to place. It's really understanding of complex relationships between the environment and community, and incorporating community values and sustainability, as well as a reverence to nature and the environment. So going to the next one. So you're probably thinking, now how can I incorporate that into what I'm going to be teaching with the kids through this program? And there is a real overlap of research areas where you could actually implement the MIWIs or the field projects with indigenous knowledge, at the same time acknowledging Western science and connecting with the national next generation science standards. And so I have this little Venn diagram here of the intersection between native science and Western science. And these are some examples of subject areas where you can incorporate both ways of looking at the environment, looking at change of the environment through these various topics. And so, we're hoping that we can change the way that we look at science teaching and learning by really respecting cultural values and also a lot of the belief systems of local tribes and native indigenous people in your area. So that's like a quickie. What I'd really love to do, if anybody is interested, we could have another webinar in the future talking about how to implement this indigenous knowledge, native science ways of learning, and looking at the pedagogies that seem to really work with particularly native students. So anyway, if you guys want to give me your feedback, I'd be happy to do this webinar sometime in the future. Is that good? That's my 3 minutes.
Thanks, Karen. I also put up this slide for you to talk a little bit about in the context of ecosystem pen pals, which I think is where these pictures were from.
Oh, okay. Oh no, that's great. And so the picture on the left that you're looking at were my students at Chief Kitsap Academy. That's the Suquamish Tribal High School. And we did a cultural exchange through the Ecosystem Pen Pals program, where we went to Hawaii. We were pen paling and talking about climate change and ocean acidification issues that both of our communities were facing. And then we were doing service learning projects. And so this one, might be something that you might want to think about doing in Hawaii. And so we went to a traditional ancient fish pond, and we were doing some algae removal, at the same time learning about cultural practices in fishing. So we were able to share with the Hawaiian students how the Suquamish are really a fishing and ocean culture, and then contrasting that with what was going on with traditional practices and service learning over in Hawaii. So that's that slide. Oh, and on the left, we're doing some water quality monitoring in our streams, and they have an active salmon migration stream on the reservation and Suquamish, and so that was our service learning project, was really to focus on salmon.
Cool.
So anyway,
Thanks,
that's
Karen.
those slides. All right, thank you for sharing those.
And Nicole was going to tell us about this odd term to most people, but to people who are involved in the BWET program, it's well understood. So, but Nicole's going to give us an introduction to it.
Okay, so yes, as Jason said, and you might have heard Karen speak to it when she was talking about some of these action projects, but MIWIs, these are meaningful watershed educational experiences. I mean, these are really the bread and butter of these BWET grants. It's all about getting students outside. They're learner-centered. They're focused on a question, problems, or issues. And then it's all about investigating and following these steps. So as a classroom teacher, you can support these MIWIs with your students by having them go through these steps. So you want them to research the issue or that local phenomena that's going to fuel your investigations that you're looking for. And that can be done in the classroom, that can be talking to community members, you can bring specialists in to talk about things. And then once you guys have your kind of topic picked out, you want to work together to come up with field activities. And those field activities are going to follow protocol that already exists. So the students need to learn that protocol so that they can go out and collect good data. They can explore models that can help them understand that data more. And it's all about examining this natural phenomena that you guys have established as your kind of topic or focus for this. Once you guys have had an opportunity to go out into the field and really collect that data, and everything that Jason's going to share with you today and the background that Karen is going to provide is really going to set you up to provide these robust MWEs, meaningful watershed educational experiences. You don't want to stop at just understanding the problem and collecting the data. You want to engage your students in action projects. That is really what it's all about, is having the students engaged in service learning. Whether you're in Hawaii and you're helping them through their projects, you're doing salmon restoration, or you're investigating salmon and coming up with community responses to keeping these environments healthy. You need an action project, and then you want to wrap it all up with a conclusion. So give your students an opportunity to share the data and their thoughts on this. Why was that action project relevant to the data they collected around the phenomena that they're experiencing? I also know that Jim's on the phone from Hawaii, and so he also coordinates BWED over there, so he'll be able to support you with information around MWEs. I hope I'm not talking out of turn here, Jim, but it is a great opportunity to delve into some meaningful field investigations with your students.
Great.
That's it.
Thanks, Nicole. I thought what we would do next is to introduce Sean again, who's going to give us a very brief overview. When we were at our last workshop, he came on and gave a very detailed overview for us about the Earth Echo Water Challenge and looking at the test kits. We have test kits to send out to our partners, partner teachers in Hawaii and American Samoa, and those will be going out in the mail shortly. This will give you an overview of what you're going to see when you get those kits in the mail. So, Sean, if you're ready, you can take over, and I'll run your slides for you.
Yeah, feel free to jump to the next slide. But thank you all so much for the time. Again, we're thrilled to be able to collaborate with everyone involved in this project. Just for a little bit of background about Earth Echo International, we are an environmental education nonprofit that was founded over a decade ago by Philippe and Alexandra Cousteau, the grandchildren of ocean explorer Jacques Cousteau, and our work really builds on a legacy of combining adventure and exploration with conservation and environmental education. And now our programs are all specifically focused on inspiring young people to act now for a sustainable future. We have a number of programs that support that mission, but one of those that we're excited to have you all involved in is the Earth Echo Water Challenge. You can go to the next slide. There we go. So just to get a quick overview of the Water Challenge program, this is really our global citizen science program. It is designed to connect young people around the world to their local waterways, using water quality monitoring really as the vehicle to do that. We like to break down the program into these three major components as test, share, protect. The first part is all about getting young people and students out connected to their local waterways through water quality monitoring, collecting data on the quality of their local surface water sources. They're then able to share their data and findings through our global database at monitorwater.org. And by doing so, they join about 1.5 million people from 146 countries who've been part of this program and participated over the years. And the last piece is that protect piece. Much like Nicole just mentioned, it's really all about that action they take and how the data informs actions they can take to improve the health of their local watersheds, their communities. And we'll break those components down real quick if we go to the next slide. So as Jason mentioned, we've got Earth Echo Water Challenge test kits either in your hands or going out to all the groups involved in the program. They are really designed to look at, again, the water quality of surface waters, looking at rivers, lakes, estuaries, the ocean, not tap water, but again, obviously the watersheds that we're all investigating here. And these test kits look at 4 key water quality parameters that you'll be able to document and record with your students. So looking at the pH, the temperature, the turbidity, and the dissolved oxygen levels. Go to the next slide. So again, just a picture of what those kits look like. They're pretty easy to use and not too much assembly, but you'll see, again, detailed instructions will come with those. And if you have any questions, we're happy to provide any support that we can as you get started. Again, just a quick overview of the testing process. We usually work with students in teams, testing the samples, recording out the results, and then, of course, that important step of reporting the findings out through our database at monitorwater.org. And again, that's where that share step and that reporting step comes in. So all of you will be able to go online, if you haven't already, to monitorwater.org and click on Add Results. You'll be able to set up an account for your school, for your class, and document your water quality data over time. We've also worked with Jason to set up a Google Doc to collect the usernames for each of the school groups and participants involved in this program. And with those, as we compile those, we'll start to build out some custom tracking tools, maps, and database dashboards that will let all of you specifically see the data coming in from participants in this program, really be able to compare and share results and findings across all the sites that are in this network. And again, that's what you'll see again at monitorwater.org. You'll be able to log in and click just that Add Results option to get started. And then once you're in the system, there's only 2 major options for sharing your data and results. There's adding a site, so saving the locations where you're collecting your data, and then adding results to those sites over time where you'll be able to document all of that water quality information. And then, of course, the last piece I just want to mention is that protect piece. And of course, that ties in so well to the work that all of you are involved in. There's additional resources and opportunities to dive in deeper at monitorwater.org/protect. And we're also excited about the opportunity to team up to tell the stories of the work that your students are carrying out. It's a big part of what we do at Earth Echo is give young people that voice and a platform to highlight their work and also share stories that can hopefully be replicated by other young people working on this effort around the world. And again, there's a little bit of our information, social media handles, and website. Feel free to reach out to me with any questions you might have as you get started in this work. And again, we're thrilled to be able to support you all and collaborate on this project. Oh, Jason, I think you're on.
Thank you a lot. Thank you very much, Sean. That was really great. I do want to just reiterate one of the things that Sean said there. The Earth Echo team is offering to essentially put together a sort of a sub-site within their site where we can gather information specifically from our project. So it will be, the data will be uploaded for the Earth Echo writ large, which covers the entire globe. But we'll also have an opportunity to be able to compare just the data from our different individual locations and to customize that page for other aspects that we might want to include, like photos that we might want to upload or other parameters that we might be measuring in our local watersheds as part of the project. So, all right, great. Thanks a lot, Sean. That's really great.
Absolutely. Yeah, thank you all.
So actually, I'm gonna stop sharing that for a moment and just because I want to skip forward, I want to include something here that I kind of forgot about, and maybe I put together some photos from our event, and I realized that I probably should show these right now, or at least one set of them, so that we can get a sense for what we did in the field here. So that would be here, and sorry, give me just a second. I lost my little. Okay, well, I lost my share button. I'm sorry, folks. Give me just a second and try to find it again here. Oh, there we go. Okay, sorry about that. Okay. So here we go. Sorry for the delay there. These are some pictures of us on that lovely Northwest rainy day that we went out into the field to do some stream monitoring and just kind of use some of the monitoring equipment that we have. So Karen or Nicole or both of you, would you like to maybe just kind of narrate this slide a little bit and talk about what we were doing in that stream and what kind of things all of our participating teachers can do in their local ecosystems?
Do you want to go ahead, Nicole, or do you want me to?
You want to start?
Sure. We put together kind of a teacher's guide for stream monitoring, and there is a curriculum that will be available to all the teachers. And we are looking at stream health and whether or not it could support fish and fish migration, and looking at water quality to see if that could also support particularly salmon. So we were going through a little teaching and learning activity on measuring stream quality using chemical test kits and looking at water quality that way, looking at the habitat and riparian area around the stream, as well as looking at macroinvertebrates as biological indicators of stream health. And so we kind of went through that and I've been doing this with students and teachers for many years, and it's very doable, engaging, and could be a really good program that's doable in Hawaii as well. You may not have fish that are migrating through the streams, but you can look at stream water quality. I'll let you go ahead, Nicole, and chime in.
Yeah, I would just follow up on that to reiterate when we talk about MIWIs, the idea of these MIWIs is to help your students have an understanding of basic watershed concepts. And so getting them into the field and looking at stream monitoring is a really great way to explore water quality, to look at the riparian zone along these streams and waterways. And then obviously all of our water ends up in the ocean. So a healthy watershed makes for a healthy ocean, makes for a healthy us. So just getting out there and looking at as many parameters as you can, both observational data and actual hard data collection while you're out there is, I think, really important. And we were out on a very rainy day, and I will say our teachers in Washington State don't have the luxury of waiting for good weather all the time to get out in the field to get and collect that data. And that's part of what this is all about, is learning to use that outdoor world as your classroom, rain or shine. You know, it's important to get out there and just find comfort in the natural world. So I think all of these things lead to that with our students.
Right, and one of the things that I think was that we were also when we were in Forks, we had teachers bring their microscopes as well with them, and we wanted to model something that we would really highly recommend doing, which is taking advantage of doing things in the laboratory and connecting that to what the experiences in the field. So in that lower left picture, we're doing some collection of stream invertebrates, and then we brought them in and looked at them under the microscope. And we have some curriculum materials included in the packet that talk about how you can relate stream health to the diversity of invertebrates that you find in a stream. And so those kinds of things where you're bringing in samples and testing them in the laboratory, especially bringing in live things to look at. And one of the things that we're not showing here is that we also went out for a very, very late night low tide to to the ocean and collected some samples to bring in as well to have a look at in the lab. So that that connection between the outdoor experiences and the laboratory experiences and documenting that and relating it to environmental problems in the classroom, and then having the students document through photos and videos what they've been doing and tell the stories about that they can share on the online platform that we developed that I'll tell you about in a minute. That's basically the whole idea of the project. And so I skipped forward a little bit there. I'm going to back up now and go to where I was a second ago and talk a little bit about one of the sort of intellectual topics that I think is not only sort of a background for the project, but I think is a really empowering concept when it comes to teaching students or about these large environmental problems and how they relate to local issues. So I wanted to start with this quote, "The ocean is a major influence on weather and climate," which is ocean literacy principle number 3. And I'll ask you to think about this question. The ocean absorbs what % of the carbon dioxide and methane that we add to the atmosphere? The answer is about 50%. And for many years, that was kind of considered great because we're pumping all this extra carbon dioxide and methane into the atmosphere, and that contributes to global warming, as we know. And so it's a good thing the ocean is there absorbing a lot of this anthropogenic carbon, because then it would otherwise be going to the atmosphere for global warming. So that was sort of the perspective of most people, myself included, until about 10 years ago, at which point we became aware, many of us, about the reality of ocean acidification when carbon dioxide enters the ocean and acidifies the water there. And so now that massive absorption of excess carbon into the ocean is now seen as a very, very large problem. And that's one of the big problems that we want to address in the course of the project. And here I've put together in a single slide, this sort of concept that I want to, that I was alluding to, this empowering concept, which started in a project that I did a couple of years ago in California called Follow the Water. And this is the Follow the Water concept, which we want to carry through to the Bonds Across the Water project. So humans are largely responsible for current climate change, near future climate change, and our acidifying ocean. So the question that we want to ask as active scientists and citizens is, what effective actions can individuals and communities undertake to reduce these impacts, our impacts that cause these problems? And so the first is what you mostly hear, and this is extremely important. We need to reduce our carbon dioxide production, our anthropogenic carbon productions. And these are local actions that we can all take to reduce carbon, and it has global implications. But this can also, at the same time as this is really important, it can also be a little bit somewhere between frustrating and defeating, because the local actions are so small compared to the scale of the problem. So we want to add sort of a second scale here, a purely local scale, local actions that have local and regional implications. And you can do that by reducing all kinds of additional stressors on local aquatic ecosystems through watersheds, in the ocean, and so forth. And this is the project, and this is the concept of multi-stressors that I want to get to in just a moment. For the first part, though, the local actions with global implications of reducing CO2, I'm going to show you this website in a minute, this International Student Carbon Footprint Challenge, which I've been working on with colleagues for many years, where we empower students to figure out what their impacts are and to figure out effective ways to reduce their carbon production. And I'll show you that, our carbon footprint calculator. And but this second concept, this concept of multi-stressors, is one that I really want to multi-stress here, because this really empowers teachers and students to be able to take local, meaningful actions that relate to the climate problem. organisms in their environments are not only facing challenges from climate change, they're facing challenges from all of these other stressors as well. And many of these other ones are issues that we in our local communities can take action immediately to reduce those stresses. Overfishing, pollutants, excess plastics, noise, big issue here in the Northwest with whales, and fertilizers and harmful algae, habitat loss, and so forth. Streamside restoration projects, reducing pollution usage on lawns and on roads, and so forth. These types of things will reduce impacts on our waterways and will basically reduce these auxiliary stressors while we act to try to also impact climate change in a longer term CO2 reduction strategy. So this concept of multi-stressors is really an empowering concept for taking all kinds of actions, and it's how we suggested to our teachers in Forks and how we suggest to the teachers in Hawaii and American Samoa to think about the concepts of climate change and ocean acidification and how you in your local communities can make meaningful change, can go out and identify problems in your ecosystems and figure out ways to try to address them. So this concept of multi-stressors is an example of how you can take a problem and approach it from multiple angles. Another way of thinking about that is systems thinking, which is a big concept in education right now. And one concrete example of systems thinking is a food web. And here's a cartoon of a Eastern Pacific Ocean food web. And you can see that there are showing all kinds of interactions in the ecosystem here, from top predators down to primary producers and everything in between. But this systems approach is still a minimal systems approach because it's missing, well, it's basically missing one big organism that influences this ecosystem, which is the human organism. So we ask the teachers in Forks, so we encourage them to think about the kinds of issues that they want to address in their classroom using systems thinking and including more of these concepts of other stressors that come from humans and maybe non-human stressors as well, that you can add into this food web to make a grander systems approach. And so I want to show you one of the concept maps that, that one of the teachers in our groups of teachers in our workshop developed. So this, you can see, is similar in a way to that food web, but it includes a lot more information on things that the students can do and the communities can do, and the teachers' ideas for how to integrate the projects that they want to do with their students into this concept of this food web, and here with salmon, orca, and keystone predators in this particular case. So that was the concept of multi-stressors. The other concept that I mentioned is this one, and I realize I'm not showing you the slideshow here. So I'm going to actually switch here and go to a new sharing to have a look at, let's see, sorry. And I want to show you this here. This is this website that I alluded to. It's Inquiry to Student Environmental Action. And this is the, this has got a series of, there's the Follow the Water project that I mentioned before, the International Student Carbon Footprint Challenge. Looking at the International Student Carbon Footprint Challenge website, we can take a look here at the carbon footprint calculator that I told you about. And this carbon footprint calculator is got a version for middle school and high school, and it's in English and Spanish right now. And here's the calculator. I've logged on myself, and I'm going to try to expand the screen here a little bit so you can see a bit more. I've logged on to the calculator here in the advanced version, and I'm at the University of Washington. I've listed my location. I could change my location to, for example, American Samoa. I could also change my state to Hawaii. And by doing so, it actually just now recalculated my, whoops, it actually logged me out. Sorry, give me a second. So let's do it this way. American Samoa, just change my state. And so now I'm listed as American Samoa, and I can see a recalculation of, well, I have to go through the calculation here to see my results. But the calculator, whoops, has got a series of 50 questions that are in home, food, purchases, and transport. We can take a look at a couple of the questions here, like, for example, heating, what you heat your home with. Then what would be more relevant in the islands would be cooling systems, fans or other systems, and so forth. In the food section, you can give a detailed answer of all the things that you eat. So if I say, for example, I'm not a vegetarian, then I can go here onto this screen and enter in how many of each of different kinds of meals I have per week, and it'll tell me down in the bottom here what my carbon for that question is. And then here, for example, is a transportation question. And so what we do in this project is we have classrooms come on, all the students calculate their carbon footprints, and then on this map here, we have all the different participating schools that have been involved in the project in the past. There's, let's see, a school here in Portugal. Here are some schools in the United States. We've got a participant from French Polynesia, and so forth. And the pins here are color coded by the time that the session, what year and season the group participated in, and it gives the total footprints of the class, the mean total footprints of the class, and in the 4 different areas. So that this tool allows students to be able to see not only to look through what their own personal impact is, but they can go back in the tool and they can play around with it, changing virtually their behaviors and seeing exactly what effect that has on their footprint totals. So, and they do that through that on the calculate page, as I showed you, through the bar at the bottom, where you can see exactly what the footprint total is for each individual question. So later on in the spring, we'll be calculating footprints of everybody in the project, and that'll be something that we'll be sharing on the discussion forum. So we're in the process of building out a discussion forum for our International Student Carbon Footprint Challenge project. This is what the discussion forum looks like. I went to this discuss link up here in the upper right, and here you can see that there have been some recent posts from students in different countries recognized by their flags here, and Dinek has posted that one of the easiest ways to reduce your carbon footprint is to change your diet. And those are some suggestions that this student has made, and other students have responded in turn to that. And so this online forum here is the method that we are going to use, a separate page of this for the project to be able to have students in Washington, American Samoa, and Hawaii post about their projects that they're doing, post video and images here in the forum, and share with one another in an ecosystem pen pal-like way, but in an immediate way where you don't have to wait for a letter to come in the mail, but you post online and you can see immediately what other people have posted and go on and post on your replies and comments yourself. So that's the that is what what I mostly wanted to share here about multi-stressors, the follow the water concept and how it relates to our project. And just moving forward here a little bit. Whoops, sorry. So just to show you a few other images from the workshop that we held in Forks last month. We started off with some fish printing, and there was some beautiful art hanging on the wall the whole time. We talked about the stream monitoring that we did on the first day. It was a 2-day workshop. On the second day, we did a series of lab activities on ocean acidification. And these activities are hands-on laboratory and simulation type activities where you can study the problem of ocean acidification and learn about the chemistry, see with your own eyes how carbon dioxide will change the pH of solutions, and so forth. And all of these activities are documented on a thumb drive that we distributed to all the teachers in Forks, and we'll be sending to all of our participating teachers in the islands, and are also going to be posted on a Google Drive, which I will be shortly sending out the link to everybody. So that's going to be a mirror of this thumb drive that you're going to get. So all of the lab activities, the lesson plans associated with them, the background information is all listed there. And some of the materials for doing these activities are going to be included in the kits that we'll be sending out. So, and speaking of the kits that are going to be sent out, they will include the water monitoring kit that Sean Russell told you about. There's some Write in the Rain notebooks, some of these materials for doing lab activities, some slides and cover slips for being able to do laboratory microscopy to support that, and then some the thumb drive and a few other items that'll be included as well. There's a water monitoring infrared laser, basically, that will help you monitor stream temperature, for example, from the shoreline. So, and then the sort of, in a way, the culmination for the teachers who participated was brainstorming classroom implementation ideas. And here are a couple of the teachers talking about their concept maps that they put together. I showed you one of them a little earlier, and here are a few other ones that they put together, added to as we went through the activities, talked with each other, and this is their presentations towards the end to the group, talking about what they're planning on doing with their students over the course of the year, and in some cases thinking sort of long-term about things that they'd like to do in years to come beyond the timing of the Bonds Across the Water project. So, so what's the next steps for the Bonds Across the Water project? In late November and early December, I'm going to be, well, in the next couple of weeks, I'll be sending these kits out that in late November and early December should be arriving in Hawaii and American Samoa that I described, with those items to help support the project. It'll also have the field notebooks, a bunch of curricular resources that'll be included in the boxes as well. And those may be distributed through the local NOAA office or directly to the teachers, depending on the location of the teachers. And in early 2020, all of the teachers involved in the project from Washington, Hawaii, and American Samoa will be undertaking these MWEs with their students. You can get started earlier than that. We envision it starting at least in early 2020. We'll be using the Earth Echo Water Challenge, the test kits that you'll be getting to record the data relevant to the project. We'll be doing our carbon footprint calculations and starting getting used to the website with a comment forum. And then the students will, at that time, be documenting all this field work and activities in and outside of class through images and video that we would like to have them upload to be able to tell the stories of what they're doing to their colleagues around in the other locations. And the online forum that I showed you is going to be the location for being able to post those images and video. And I'll be sending out detailed instructions on how to use that forum and post video. There's a link on the website, and I'll send it around to you all as well. So that'll be in early 2020. And then as we get into the Northern Hemisphere spring, later on in the spring, we'll be, and into the March and April, we'll be actually doing this sharing on the website, doing this e-pen pal approach around the Pacific Rim, and discussing and commenting on one another's posts and meeting one another and inspiring one another to take action and documenting those actions when you take them. So, and then finally, as we get towards the end of the school year in May and June, we'll be asking you to do some evaluations at the end of the project, and for all of your efforts in here coming on for this webinar and taking part in the project with your students throughout the year, having your students comment on the online forum, meeting the other teachers that way as well, and then doing those evaluations at the end. We'll be sending out stipends for you as a partial compensation and thanks for your participation in the program. So that covers what I wanted to present. I want to just ask Nicole and Karen real quick if either of you had anything else that you wanted to add that you thought that should be mentioned that I may have forgotten or we may have forgotten at this point.
I think you did a good job of covering it, Jason. I mean, condensing 2 days into an hour. So great job there. I thought that was excellent. I guess I'd just like to say, certainly by email, I'm happy to be a resource for anyone that has questions, or if you're looking for certain resources. We, physically will be trying to work with the teachers in Washington State, particularly. I already am out on the coast, so it's easy for me to support teachers that are adjacent to the coast. But yeah, I think part of the beauty of this project is creating a working group of people around the Pacific that you can use to bounce ideas off of and kind of inspire each other. I think both teachers to teachers and students to students, hopefully. So I'm excited to get the project going.
Great. And just a second, if you wanted to say something, Karen. Just
oh yeah, hey, I'm excited.
Me. Go ahead, Karen. Go ahead.
No, I'm excited and really look forward to working with teachers in the classroom. And so if they do have any questions or want any resource materials, to contact me by email. And I just really look forward to the students interacting with each other. I think that's the most fun part of the project. So looking forward to working with everyone.
So just to follow up briefly on something that Nicole said there, in terms of contacting us one method that you can all take advantage of, I set up this email list with all the participating teachers. So if you have something that you want to share out with other of your colleagues, you can use that email list. And I have it moderated so that that actually prevents spam on that list. But I'll be checking it and sending out those messages as they come in. So if anybody wants to use that email list to send out messages to everybody, you can do so. But in addition to that, once we get the website launched with the conversation forum, there's a teacher stream there too, so you can practice on the website basically and use that as a method of being able to get to know the comment forum that we've set up, and also can use that to contact other teachers or to share resources that way as well. So, and then of course you could just contact us directly. You all have my email address, and I'll make sure to forward Nicole and Karen's email address to anybody who doesn't have it as well. So I also just wanted to open this up to anybody else who had any questions or comments that they wanted to add, any of the teachers who've participated before, or Nole, I think that if you had a question, you'd have to type it in, unless your microphone is working now. But I just wanted to see if anybody else wanted to chime in any way before we wrap it up.
Hi, aloha. I'm not sure if you all can hear me.
Oh, aloha. Hi, Jennifer.
Hi, sorry, I came in a little late, and I just had a question about what exactly, what kind of field data are you collecting?
Mm-hmm. So one of the things that you're going to get a kit, a water quality testing kit from Earth Echo, which includes pH, turbidity, temperature, and dissolved oxygen. So those are some parameters that you can measure. And we also have these temperature probes that we can give you. One of the things that is kind of a neat project for streams and is really important all over actually, and would be important in Hawaii as well, is looking at temperature variation during the day, depending on the time of year, depending on the intensity of sunlight, and how it warms the stream directly. For example, and you can walk a stream and look at areas that have good vegetation cover and others that maybe don't have good vegetation cover, and you can take some data on differences in terms of water temperature, which can be really important obviously for the organisms there. So that's one kind of activity that you can do with those infrared guns that we will be sending out. And we talked a little bit earlier also about looking at invertebrate diversity in streams, and so we have this image that's up right now, this stream monitoring here is showing in the lower left some of the sampling that we did, and the lower left is showing invertebrate sampling and looking at stream health by looking at those issues. There's going to be a whole bunch of curricular materials that are going to be coming in the boxes to you, and will include a whole bunch of other ideas about looking at culverts that run under roads and so forth, and thinking about it in terms of stream health for us, for fish migration, but also for just stream health in general, and how the water quality parameters relate to that. So the connection of that to the concept of multi-stressors is the health of the stream. As you all in Hawaii, there's a lot of really big news, always is, but now recently I've been reading a lot of big news about some watersheds in Hawaii where there's some really politically charged issues related to stream usage and water usage for things like golf courses, and how that and how usage of water impacts the nearshore coral reefs and so forth. And so the impacts of climate change on coral reefs are something that are ongoing and are inevitable to a certain degree, hopefully not as bad as it could possibly get. But what we can do in the meantime is, if we can reduce some of those freshwater input stressors on nearshore reefs, then your students can act immediately to try to mitigate those problems. And so that's those are some of the concepts that we talked about. Does that help,
Thank
Jennifer?
you.
Yeah.
Yeah, it does. And does that extend at all to any monitoring in the ocean?
Yeah, so you know, we do have some you know, doing monitoring in the ocean is a little bit more challenging. At the lower right there in that stream monitoring picture, Nicole is showing off these cool little pH devices, these fighters that you can get pretty good field data. Getting ocean pH is difficult. You need pretty good equipment, and that actually is a cheap, pretty decent equipment. I don't know if the NOAA offices in Hawaii would have anything that that teachers could use. I don't know if Jim could comment on that, or Nicole.
Well, this is Nicole. I can comment on the fact they probably don't have fighters yet. They're being produced by Sunburst Sensors, but the beauty of this fighter is it was developed by a community college student in Montana with his chemistry professor, and it was picked up by Sunburst Sensors, who, until they started working with the fighter, make, you know, thousands and thousands and thousands of dollars instruments, expensive ocean monitoring instruments. So I will work. It would be great to get these in the hands of teachers that are participating in this project if we can. So I'll work with Sunburst and William and David, the two developers that we've been working with, to see where it's at and see if we can't find some funds to get these into the hands of teachers.
Mm-hmm. But that would be great. But and although I said that that having good pH monitoring equipment is kind of necessary in order to get really precise data in the ocean for pH, there are some things that you can do in really broad scale looking at pH. For example, we were talking about, since we went out for a nighttime tide pool, there are huge fluctuations in pH that happen as a result of the during the day and night as a result of photosynthesis and respiration in nearshore tide pools. And so that's something that you could actually monitor with your students, and you can, and the results can be so dramatic that even with a fairly coarse-grained pH monitoring device, you can probably see those differences. Jim, did you have something you wanted to say?
Yeah, I don't know if we have any instruments. Some of the fish pond organizations may have some instruments that can do that. But also within pH monitoring, there's the University of Hawaii Ocean Time Series has a site 60 miles north of Oahu, sort of representative of the islands, that makes monthly cruises. And if you look up the University of Hawaii HOT program, you can download the data. You can also get the atmospheric carbon dioxide data from Mauna Loa on that site as well.
Great. That sounds good.
Jason,
Jim, your audio was a little bit scratchy there. Would you mind typing in the site that you mentioned into the chat?
Sure. Let me find it, and then I'll type in the link to it.
Thanks. That'd be great. Karen, you had something you wanted to say?
Oh yeah, I just wanted to add, you know, in Hawaii, they can also not be limited to just chemical monitoring, but you might want to consider doing beach monitoring and looking at doing a habitat survey, for example, looking at substrate habitat for marine invertebrates, and maybe doing something like a presence or absence survey of various marine invertebrates that you find out on the beach. So, you know, those are just a couple ideas, but you're not just limited to measuring pH and temperature.
Right.
You can kind of look beyond that.
That's right. That's right. and I mean, and maybe I don't know what you do with your students if you ever have the opportunity to get in the water with them to be able to look at look at any compare some environments, impacted, non-impacted. Well, most of the reefs are impacted, but impacted and less impacted reefs. To look at the diversity is obviously would be incredibly cool. And if anybody's got a video that they can take of that, that would be an incredible thing to post onto our website. I'm sure everybody would love to see something like that.
All right.
So let's see here. Was there any other anybody want to chime in and say with any other comments or questions or perspectives or thoughts before we wrap things up here? Great. Okay. Well, thank you all so much for coming and joining in with this. Jennifer, as I mentioned probably before you came on, this was recorded, so you can actually go back and see the earlier part. At some point, I'm going to figure out a way to post it, and then you'll be able to go back and see the earlier part of the webinar that you missed, and the other teachers that weren't able to make it today, hopefully we'll be able to catch up too. And so, yeah.
Jason, could you send the recording when you figure out how to Lucy, please?
To what?
Lucy Ross from my school.
Yes. So, so what I'm going to do, yeah. So Lucy is now on our email list. I just added her today, and I will be using that email list that I sent out, and I'll give the link once it's posted, so everybody can get a chance to have a look at it.
Thank you.
All right.
And this was actually a really great recap because I was not feeling good that day.
Oh.
Right. Well, good. And I will I'll take this group chat here and also send it out because it's got some nice links on it. So I'll send that out to the email list as well. And so thank you all so much. And I really look forward to working with you all throughout the year and seeing what cool things you do with your students. So have a great night.
Okay, mahalo.
Night, night.
Bye-bye.
Bye.
Thanks. Bye, everyone.
How do I get out? Nope, that didn't work.